the most common neurotransmitter that is used in long-term memory is something called glutamate. That's an amino acid. We often just abbreviate it, GLU. So this is the neurotransmitter that is indicated in long-term memory. We use a lot of glutamate. And the other thing that we see is we see the production of new, novel, meaning that they weren't there before, right? So a different type of glutamatergic receptor. Now, the first receptor that's formed, so these are both glutamatergic receptors, which means they would both bind glutamate and trigger a response. And they are excitatory, right? We don't want an inhibitory, so they're going to trigger depolarization in the postsynaptic membrane. So they're going to create what we call an EPSP, an excitatory postsynaptic potential. So that means depolarized. This first kind of receptor that's formed here, so we got to differentiate between these two kinds of receptors. And remember, we're going to name receptors not based upon what they bind in the cell, but what they bind outside of who we're studying. And I can't remember what these acronyms stand for, so I'm sorry. So this one is called AMPA, which is some chemical, AMPA, some chemical, I can't remember what it is, that this would bind. And this one, this new receptor here, is called an NMDA receptor. It would bind NMDA, and I can't remember what that stands for. So that just means that that's two different kinds of receptors that are found on the postsynaptic cell membrane that will both bind to glutamate and trigger a depolarizing excitatory potential in the postsynaptic neuron. So this is a neuron, right, because it's in the CNS. You guys okay with that? All right. So let me show you this kind of and walk you through what this looks like in the body.